Aerobic exercise prescription. This video help you to make your own aerobic exercise prescription. This is our Lab 4 Canvas website. So your Lab 4 is a 1.5 mile running lab or 1 mile walking lab, is right? So you should walk 1 mile or run 1.5 mile run, right, to report either of one. How about that? Doesn't make sense. But just in case, if you cannot run or if you cannot walk, Noah, at this time, right, at this time, you can use Dr. Kwon's video about Dr. Kwon's 1.5 mile run test, or you can use Dr. Kwon's 1 mile Rockford walking test to report Lab 4. Doesn't make sense. But for Lab 4, there are one assignment inside. That is, you need to make your own exercise program. Did you remember it, right? You already read, right? But this case, if you didn't run 1.5 mile run, or if you didn't walk, is 1 mile walk, how can you make your own exercise program? So this is why I put non-exercise test for predicting VO2 max documentation. Doesn't make sense? So you can report using Dr. Kwon's video, but you can put your own exercise program just in this lab assignment. So doesn't make sense? Doesn't make sense? So non-exercise test for predict VO2 max. This is for students who couldn't run or walk, but still report this lab report. How about class? Does it make sense? So your lab 4 is a problem-solving lab. The due date is right now, December 8 to Tally and December 11 to Dr. Kwon. Yeah, so to tell the truth, if you choose a walking or 1.5 mile run for your data, right, using your data, that case, I believe you do not have any problem to finish, is right? Yeah, doesn't make sense. But however, if you cannot test yourself at this time, you can use Dr. Kwon's virtual lab for your lab report. Doesn't make sense? And non-exercise test for predict VO2 max 1, that documentation for your exercise prescription, especially students who didn't run 1.5 mile or who didn't walk 1 mile either. So today our lecture about this one here. This is your lab 4 in the documentation between discussion and reference. So exercise program 10 point. For full credit on this lab, you must make your own cardiorespiratory exercise program. But your exercise program will be done with Dr. Kwon using Zoom meeting or recorded video. So right now I'm recording videos, right, to finish with you. So to make exercise program is very important because you are kinesiology majors, right? I believe around you there are many friends, they know you are kinesiology major. So they need exercise program. I believe they never ask you what is the fast bucket system, what is the glycolic energy system. Not like this. They ask, I need exercise. Could you give me exercise program, especially cardiorespiratory fitness? How about class? Does it make sense? So this today is the lecture is really important as a kinesiology major. As you know, I promise I'll use your own data, is right? So it's much easier for today to just follow me. But I do not want to show your data, your name, but I want to show your initial. So this is why I develop your initial is here. But sometimes student needs overlap. So this is why I put like that RT. If you see here, there are two RT. Is the first name, is the last name same. But this RT is for female student's name, or this RT is male student's name. How about that? Doesn't make sense? We have two MC, but one MC is a student 22 years old, another MC student 23 years old, like this. So you can distinguish between another same initial, is right? Yeah, doesn't make sense? I think it's understandable, is right? So please take a note your initial. And next one is, this is right now I just use your initial. And to make exercise program, body mass is important. And another one is your VO2 max, or your client, your friend's VO2 max is important. So actually, I just put VO2, but this is VO2 max. VO2 max. So RT student's body mass is 68.2 kilogram, and VO2 max is 46.4 milliliter kilogram per minute. Is right? Yeah. So we import these are two important things to make exercise program. But why does it mean this red color mean a student didn't report their VO2 max value or incorrect value, or maybe a little bit correct but a little bit different than my calculation? So this is why I put here. So this is why it took a time for preparing this lecture, because I really want to fix all of the students' data, and I can really give a good lecture using your own data. How about class? Does it make sense? Does it make sense? So please take a note your initial and your body mass and your VO2 max value. So if you click your aerobic exercise program sheet for lab 4, and the documentation is this one. So I already posted. So you need complete this program design, and you can add, you can include your lab 4. How about class? Does it make sense? If you have a printer, please print out. But if you do not have a printer, you can just manually write. You can use just one paper, manually write, and take a photo or scan, and you can include your lab 4. How about class? Does it make sense? Does it make sense? Yeah. And another one, this is kind of programming. How about class? It makes sense, right? So I believe you exercise without really exercise program. Class, do you agree? Do you agree? Yeah, so I think today is a really good time you learn how to make an aerobic exercise program, cardiorespiratory fitness program. There are some prerequisites to make exercise program requirement. So for example, did you remember I said to make aerobic exercise program, you must know body mass as well as which one? VO2 max is right, VO2 max. But did you remember lab 3, to measure VO2 max, we need metabolic cart, and it's expensive, and right now it's not available during COVID-19. Is right? So we need a field test. So this is why Dr. Kwon, right, is introduced 1.5 mile run test or 1 mile walking test. And another one, did you remember Astrand bike test? I showed this, right? So using bike, you can predict your VO2 max too. So this is kind of field test to measure your VO2 max value. How about class? Does it make sense? Does it make sense? So first, you need measure your or calculate your VO2 max value using field test. There are some kind of concept you should know. So how about class? What is the resting oxygen consumption? That is 3.5 is right. 3.5 milliliter kilogram per minute. That is our resting oxygen consumption. But to easily calculate, like today, like exercise programming, is a 3.5 milliliter kilogram per min. There are some unit we call metabolic equivalent. So we just promise 1 met equal 3.5 milliliter kilogram per minute. How about class? Does it make sense? Dr. Kwon, what is this? We need this one to calculate exercise program. How about class? Does it make sense? I would like to read. One metabolic equivalent, MET, is defined as the amount of oxygen consumed while sitting at rest and is equal to 3.5 milliliter kilogram per minute. And another one, ACSM equation. ACSM equation. Another name is ACSM metabolic equation. ACSM metabolic equation. I just put is a little bit like a number here is right. Oh my goodness, that is complicated. But how about class? I really want to make it easier for you. So please watch here. How about this one? So this is the ACSM walking equation. ACSM walking equation. So using our speed or using our grade, if we use like a treadmill, if we know that speed and grade, we can calculate our oxygen consumption. How about class? Does it make sense? Does it make sense? It's like this. Oxygen consumption equal speed multiply 0.1, that is a constant, plus grade, this is percent grade, and multiply speed multiply 1.8, this is constant value, and plus 3.5, this is ACSM walking equation. How about class? Doesn't make sense? But this should be walking, during walking. you cannot use running for this equation because this is walking equation. Is it right? Simply VO2, oxygen consumption equal speed multiply 0.1 plus grade multiply speed multiply 1.8 plus 3.5. But you should be careful the unit, because this grade is a percentage, okay? So 20%, that case you put 0.2, is like this. And how about this speed? This is meter per minute, is a meter per minute. So mile per hour, to convert meter per minute, you need some equivalent. How about class? Doesn't make sense? But unit equivalent always like provide this, so you do not need to worry about, but you must understand the concept. So this is ACSM walking equation. And how about doing learning by doing, right? So how about why not we just practice? So Sam, 65 kilogram, is walking at 3.5 mile per hour on a 10% grade. What is his VO2? So class, could you do that? Is it right? Could you do? Yeah. So how about like this? So 3.5 mile per hour, but did you remember I said this speed is VO2, this speed is a meter per minute. So we must convert meter per minute. How? Because 1 mile per hour equal 26.8 meter per minute. So we can calculate like this. So if someone walk at 3.5 mile per hour, so we can calculate, it means, oh, the speed is 93.8 meter per minute. How about class? Doesn't make sense? So 3.5 mile per hour is equal to 93.8 meter per minute. So we can put 93.8 meter per minute, and the constant 0.1 is right, 0.1. So that number is 9.38 milliliter kilogram per minute. How about vertical part with incline, with grade? How about here? Oh, 10% grade. So 10% grade is decimal number is 0.1, is right, 0.1. And speed we already calculate 93.8, is right. And the constant is 1.8. The equal is 16.88 milliliter kilogram per minute, is right. And the last one, 3.5, that is resting. We always consume 3.5 milliliter oxygen, yeah, even at rest, is right. So we need to add this number. So add this one. So add all of them equal 29.76 milliliter per kilogram per minute. So using ACSM metabolic equation, especially this is a walking equation, we can calculate oxygen consumption. How about class? Doesn't make sense. So Sam is walking at 3.5 mile per hour on a 10% grade. At that time, his VO2 is 29.76 milliliter per kilogram per minute. How about class? Does it make sense? Next one is running with grade. So this is ACSM metabolic equation. Yeah, but this is running with grade. What is the difference between running and walking? Just constant. Class, please watch here. VO2 speed multiply 0.2. So this is 0.2 is a constant for running. Did you remember? Is our walking. 0.1 is right, but running is 0.2. And plus grade multiply speed multiply 0.9. How about class? Did you remember our walking is 1.8, but running is 0.9. See, it's just different constant value, right? And plus resting value 3.5. So especially faster than 5 mile per hour, we need this equation, running with grade. Class, doesn't make sense? Simply VO2 equal speed multiply 0.2 plus grade multiply speed multiply 0.9 plus 3.5. This is the ACSM metabolic equation for running with grade. And another one, how about class? If you run a flat, right? How about if you run is outdoor, no grade? That case, how much percent of this grade? That can be 0, is right? So this case, if we run outdoor on flat, that case is this equation is so simple, like this. Speed multiply 0.2 plus 3.5 because grade is 0, is right? So you do not really worry about this number. So very simple. Speed multiply 0.2 plus 3.5. So why not we just practice together? So this is equation. How about Imorgene 65 kilogram is running at 4.5 mile per hour. Oh, Dr. Kwon, can you run 4.5 mile per hour? Yes, because it has 12% grade. That case, this person must run, is right? Oh, so we need to use ACSM running equation. How about class? Does it make sense? Yeah. So how about first, which we should do? Did you remember? Speed is meter per minute, not mile per hour. So we must change speed from mile per hour to meter per minute. So like this is right. So 120.6 meter per minute. So I think we are almost done, is right. So put this speed. How about constant for running is 0.2. Did you remember? 0.2. So 24.12 milliliter per kilogram per minute, and vertical part is grade speed 0.9, is right. So grade is 12% grade, so number should be 0.12, is right, decimal number 0.12, and speed is 120.6 and constant is 0.9, is right. So answer is 13.02. and resting, we have always resting. At rest 3.5 is right. At rest we need still oxygen consumption, so 3.5. So add all of them, 40.64. So somebody is running at 4.5 mile per hour on a 12% grade. That case, the person's VO2 is equal 40.64 milliliter per kilogram per minute. So doesn't make sense. Okay, so right now we know your body mass and your VO2 max, as well as how to calculate oxygen consumption using ACSM equation, is right. And you understand what is MET, right? 1 MET equal 3.5, is right. So you have some kind of like a basic information, you have a basic requirement knowledge, right? You have. Doesn't make sense. So we'll make exercise program. So first, how about class? As you see here, this is exercise prescription part, and this is kind of you should show your work how to calculate your exercise variable. So for example, like this, just simply you need to put your name is here, and you must put your VO2 max value here and your body mass here. Right? Class is right. I already show you, right? And this is phase mean is 1 to 4 weeks. So generally this is like a 4-week program. How about intensity? Usually intensity is a percentage. So 80% of intensity will do. I already set up here. Okay. So you can change, but today I just demonstrate. And another one, kilocalorie per week. So kilocalorie per week mean, so you can use, you can metabolize this kilocalorie per week. So for example, 1000 kilocalorie per week you can do, or 1500 kilocalorie per week, or 2000 kilocalorie per week, like this kind of kilocalorie. But how about this case, or this person choose 1200 kilocalorie per week? And how about class? This is important. If you want maintain your health, you need at least 1000 kilocalorie per week. You need use the kilocalorie from exercise. However, if we want improve, not improve, how about reduce, decrease? If we have a depression, but if you want decrease your depression, a good thing is right, you need around 1500 kilocalorie per week. How about class? Doesn't make sense? And the next one is, if we want maintain health body mass, or if we want reduce body mass, you need 2000 kilocalorie per week. How about, doesn't make sense? Doesn't make sense? Like this kind of approach. So I think this person, actually you right, decide 1200 kilocalorie per week. So it means this exercise program can improve or maintain your health but cannot really reduce depression because kilocalorie is not really enough. Did you remember I said you need around 1,500 kilocalorie per week? And how about can we reduce body mass? No, is right, because to reduce body mass, you need at least 2,000 kilocalorie per week, but this program is 1,200 kilocalorie per week. How about class? Doesn't make sense? Doesn't make sense? And another one, so this person, his goal is 1,200 kilocalorie per week, but FR mean is frequency. So an exercise unit is week. So it means, oh, this person can exercise 3 times per week. So 3 times per week, but 1,200 kilocalorie per week. So how about one section? How much kilocalorie per section? 400 kilocalorie. Do you agree? Do you agree? Yes. So this program is 1,200 kilocalorie per week, but per one section is a 400 kilocalorie per section. How about class? Does it make sense? Doesn't make sense? And it can maintain, improve our general health, but cannot really reduce depression, cannot really reduce body mass because it has only 1,200 kilocalorie per week. So how about class? Right now you understand between the difference between exercise and physical activities, right? Yes, this is exercise. Without this kind of programming approach, that is just physical activity or sports. So this slide, I would like to explain how to set up our exercise intensity. And to get exercise intensity, you need VO2 reserve or MET reserve method. So VO2 reserve method means VO2 reserve is equal VO2 max minus resting VO2. Upper class doesn't make sense. Oh, VO2 reserve is VO2 max minus resting VO2. Well, you know your VO2 max value is right, like 45, 50, 35. And how about resting VO2? We have some number, right? Resting VO2 how much? 3.5 milliliter per kilogram per minute. Is right? Doesn't make sense. Doesn't make sense. And another one, because to calculate exercise intensity and next one is exercise volume and other one, that case we need MET value. MET, resting metabolic equivalent is right. I'm sorry, metabolic equivalent. Metabolic equivalent, MET value. So you can just using oxygen consumption value, but you can use MET value. Did you remember? MET equal 3.5 milliliter kilogram per minute is right. So we'll convert oxygen consumption to the MET value and we'll calculate VO2 reserve. And I show the like what is this example. It'll be much easier. But how about people showing your example? It's like this. VO2 reserve method is you need first measure your VO2 max or calculate your VO2 max using field test. You already did, is right. And that VO2 max value you must convert it to MET value. It's easy, is right? Your VO2 max value divided by which number? 3.5 is right. And next one is you must determine VO2 reserve. How can do? Yeah. So you already convert the MET values, right? So MET max value minus what is the resting of our MET? It's 1, is right? So your MET max value minus 1, that is VO2 reserve value. And based on your percent exercise intensity, right? So multiply your exercise intensity to VO2 reserve and plus our resting value again, but MET is resting is 1, is right? So add 1 again, that is our target oxygen consumption or our exercise intensity. But I think it's confused, is right? But I show you the example. It's easy, don't worry. And another one, did you remember I choose 80% of our exercise intensity, is right? How to get this one? So untrained people, their exercise intensity should be 50 to 60%, or trained people like 70 to 80% of exercise intensity as well their initial exercise intensity. How about class? Doesn't make sense? But you know, you are kinesiology major. So today, just to demonstrate, I just choose 80% of exercise intensity. How about class? Doesn't make sense? Doesn't make sense? You can choose 50 to 60% or another percentage, right? It's depend on your VO2 max value. You know, you already compare your VO2 max value to the normative data, is right? If you are below average, I think you need 50 to 60%. It's a really good exercise initial intensity. How about if you're above average and like good or excellent, that case, you had to better start 70 to 80% of exercise intensity. How about class? Doesn't make sense? Doesn't make sense. And I show the demonstration. How about this purple color is my data. Today is demonstrating data, right? And how about this red one is your data. But you know, I have 30 students, so I cannot put your data here. So please prepare paper. Please prepare paper and calculate. And I show you example. Please follow me. So first, my VO2 max is 50. But you have your VO2 max value is right. I already show the table is right using your initial, right? So yeah, so please put your VO2 max value and just using your paper manually. And did you remember which one we should do first? Yeah, first you need to convert MET value. 1 MET equal to 3.5 is right. So my case, 50 divided by 3.5 is a 14.3 MET. How about class? Does it make sense? This is my max MET. So it means my maximum oxygen consumption is comparing my resting is a 14.3 times. I can exercise 14.3 times of my resting value. How about class? Does it make sense? Doesn't make sense. And please calculate your MET max value using your VO2 max value. How to do? Just divide by 3.5. And next one is VO2 reserve mean max value minus resting. But how about our consensus? What is the resting our MET? It's just 1 MET is right. 1 MET. Did you remember? 1 MET is our resting. So 14.3 MET minus 1 MET is 13.3 MET. This is my VO2 reserve. How about class? Doesn't make sense? This is just equation. It's equation. Max MET minus 1 MET. Everybody's saying 1 MET. So how about class? Could you calculate your VO2 reserve? Your VO2 reserve. Did you do? Did you do? Right? And next one is a prescribed percentage exercise intensity. Did you remember? I choose 80%, right? So please, every student use 80%. So it means this exercise intensity should multiply to this MET. So VO2 reserve multiply 80%. It means 0.8 is right. So my case 10.64. 10.64. How about your one? How much your MET? How about class? Does it make sense? Doesn't make sense. And another one, VO2 reserve method, we must add our resting value. So like this, right? So 10.64, I think is I add 1 MET. So finally 11.64 MET. So this is my exercise intensity. So my exercise intensity is comparing my resting is 11.64 resting. Doesn't make sense? And could you calculate your MET? You just follow this one. It's not difficult, is right? I think it's so simple, right? So please pause this video and please calculate your MET. Yeah, so how about I think you write your name and VO2 max value and body mass is right. How about this demonstration is my data. So when I make this scenario, my VO2 max at that time is 50 and my body mass 75 kilogram. Right? So it doesn't make sense. This is my data, but please write your name and your VO2 max, your body mass, and your VO2 max and your body mass, right? And the MET is, how about class? My one is 11.64, is right? How about class? Today we use just consensus, just using one decimal number. So this is why my MET is 11.6. So I just put 11.6 here. How about class? Does it make sense? So how about more detail? Excuse me. So write your name And your brute max value, your body mass is right. Write your mat value. How about Dr. One? How much? 11.6 is right. And please show you how to calculate your mat value. Does it make sense? Please show your work here. How about class? Does it make sense? You write your mat value and you must show your work. Okay. How about class? Pause this video and put your mat value and please show your work. Okay, did you check? Did you write down is your mat value, and did you show your work? And however, this is kind of a domino. If you incorrect this here, and sequentially you will have every incorrect answer. Right? Doesn't make sense. So I do not want to like that. So next slide, I show the answer, so you can check. How about this? It's good, is it right? Oh, oops. So this is answer. So how about class here? Our example is my own example here is right. So 75 kilogram, 50 brute max. So 14.3 man max minus 1, 13.3. This is the brute reserve is right. And multiply 80%, 10.6. And plus add 1, so 11.6. So actually our answer is 11.64, but I already mentioned we want to use one decimal number. So this is kind of my data, is right. So you have your initial is here, is right. Your body mass is here too, and your brute max. So I just show you every student's data, med max, and minus 1, and multiply this number to here. So this is exercise intensity, but this is your VO2 reserve method, so plus 1. So this is kind of our answer. It should be, your number should be like this. So if your number not like this, should go back, where is your incorrect one, right? So you can check your answer. How about class? Does it make sense? And please check. And if your answer is not correct, yeah, please fix it. So we calculate as math is right, exercise intensity. So next one is their order. Next one is kilocalorie per minute. So kilocalorie per minute, this one. You must calculate this kilocalorie per minute. It means every minute how much kilocalorie you use is right. And after get this kilocalorie per minute, you can calculate your time duration. So to calculate kilocalorie per minute, yeah, we call caloric threshold. And actually net calorie threshold, net calorie cost, but this is a net calorie cost, so you must you must subtract its resting part. So it's a little bit confused, but I show you. So how about your body mass and your exercise intensity measure, right? How about this case? This is my demonstration. So my body mass 75 kilogram, and we use VO2 reserve method. We calculate our mat is right, exercise mat. So 11.6 mat. Did you remember? This is my one. But how about this case using paper? Write down your body mass kilogram and your exercise mat. Previously you calculate is right. And this is equation, but this equation is important thing is here. So to calculate kilocalorie per minute, you must net mat. What does it mean, net mat? So this is exercise intensity mat, but net mat is unit exercise mat minus 1. So it means only exercise part. It doesn't make sense. So you need net mat 11.6 mat. This one, you calculated on exercise intensity one, minus 1 and multiply 3.5. This is equation, constant value. Multiply your body mass kilogram, and divided by 200. How about class? Doesn't make sense. And you can calculate kilocalorie per minute using this net calorie cost equation. You know your body mass is right, and you know your exercise mass you already calculated is right. So please calculate. And how about class? Pause and calculate and please check. Right? So how about this case? Did you remember? Oh, I think right. So how about our goal? 1200 kilocalorie per week, is right. But this our demonstration is 3 times per week. The frequency is 3. We already decide. We already consensus. Right? So every section, this person metabolize 400 kilocalorie, is right. So it means we have net calorie cost kilocalorie per minute. So this number, it means to expand 400 kilocalorie, right? How many minutes we need? I think we can calculate it, right? So 400 divided by this number, this is time. Class, doesn't make sense. This is decimal number time, 28.77 minutes. But if you convert this 0.77 minute to the second, just multiply 60. So 46. So 28 minutes, 46 seconds. But class, please, this number is important too. So please calculate both of them. Decimal number and min and second. How about class? Doesn't make sense. So how about pause the video? Please calculate your kilocalorie per minute. Be careful. This is net math. Don't forget -1. And another one, after calculate kilocalorie per minute, because your section is 400 kilocalorie. So 400 divided by this number is show your duration. I want to show you please show your time is a decimal number minute as well as minute and second. Yeah, go ahead. So I think you already write down your math value is 11.6. So please write down your kilocalorie per minute value as well as time, 28 minutes, 46 seconds. How about class? I said you need the decimal number too, right? We'll use later, right? So at this time, 28 minutes, 46 seconds is good. But how about 28.77? That was decimal numbers, right? So you should know that you should maintain that number too. How about class? Does it make sense? So in your paper, you should hand in this one to me, right? So please write down your kilocalorie per minute as well as time, and please show your work in this column. Does it make sense? This is for kilocalorie per minute. This is time. So this is answer, right? So how about class? So we done is +1. This one is right. This is our exercise math. I think you agree is right. Is right, right? And when we calculate kilocalorie per minute, we need net math, is right? Net math. So this number -1 is net math. This is only our exercise part, is right? This is only our exercise part. How about class? Doesn't make sense? And this net math, multiply your body mass, multiply 3.5 and divided by 200. That is kilocalorie. That is the net cost, right? So kilocalorie per minute is here. So please check. And next one is 400. This one, 400 kilocalorie. 400 kilocalorie divided by your kilocalorie per minute. It show the time, is right? But this is a decimal number time. So 3.4.2 minutes. But this is min per second. So you just can multiply 60, is right? So that case, you can have 34 minutes, 12 seconds. Like this kind of number. How about class? Does it make sense? Yeah. So please check if you have incorrect number. Yeah, please check where is your error. Next one. So we did exercise math and kilocalorie per minute and time, right? So minute and second as well as decimal number of minute is right, minute. And next one is we need speed or pace and pace. I'm sorry, speed and pace. So mile per hour as well as we need the pace is a min per mile. So how to calculate min per mile, like a speed? So actually, did you remember our exercise math is my example. 11.6 math is right. You have this one too, right? Our exercise math is developed by due to reserve method is right. So 11.6 math, this exercise math, right? And it should be converted to the oxygen consumption, milliliter per kilogram per minute. Did you remember? So could you do that? Right? 11.6 math, this is our exercise math, is right? Exercise math after VO2 reserve method, is right? And convert is a milliliter kilogram per minute. So 40.6 milliliter to kilogram per minute. Does it make sense? And please calculate your milliliter per kilogram per minute. And another one, I think you remember it, right? Is earlier of this lecture, I demonstrate how to use ACSM equation. Is right? ACSM equation. So what is the ACSM equation? Using speed as well as grade, we can calculate oxygen consumption. Did you remember? So it means if you have oxygen consumption is inversely, you can calculate speed as well as grade, is right? But how about class? I do not want to too complicated, but you can do, but I do not want to too complicated. So at this time, in this case, we just calculate only speed. So it means you exercise an outdoor on the floor or you exercise on the treadmill without any grade. Because that case, our ACSM equation is too simple. It's very simple. How about class? Does it make sense? So level surface ACSM equation means no grade. No grade. So how simple is it, right? So how about class? Did you remember? ACSM equation, oxygen consumption equal speed multiply 0.2 plus 3.5. Did you remember? Actually, we have a grade portion is here, but I ask surface ACSM equation mean there are no grade. So this is why equation is so simple. Did you remember? Yeah, go back to the ACSM equation, right? Yeah, ACSM equation. Does it make sense? Does it make sense? So this case, my exercise intensity oxygen consumption is 40.6, is right? So I just put here. And this is ACSM running equation. So speed multiply 0.2, 3.5. So to calculate speed, how about this case? I think I should minus 3.5 here and minus 3.5 here. Does it make sense? To cancel out this 3.5. So minus 3.5, minus 3.5. So this is why it's 37.1 milliliter per kilogram per minute. And yeah, still same. But there are no 3.5 is right. So minus 3.5, minus 3.5 is right. And next one, to cancel out 0.2, to cancel out 0.2. So I divide by 0.2 here, so cancel out. And I divide 0.2 here too. So this is why we have 185 meter per minute. That is our speed. How about class? Does it make sense? Does it make sense? But you know, you are not familiar with meter per minute is right. You are familiar with mile per hour. So how can we convert mile per hour? So put the 8.5 meter per minute like this, and 1 mile per hour equal 26.8 meter per minute is right. So I can cancel out. So answer is, oh, my speed should be 6.9 mile per hour. How about class? Does it make sense? Does it make sense? And next one, you have 6.9 mile per hour. Actually, this speed is for treadmill running. Do you agree? This is for treadmill running. Is right? How about if we exercise outdoor, like a track? Yeah, doesn't make sense. It's outdoor track. That case, you are not familiar with this 6.9 mile per hour speed. You cannot sense. You cannot sense. If you are a person to exercise outdoor, you are familiar with pace instead of speed. Pace mean is mean per mile. For example, my 1 mile pace is 9 minutes per mile. How about class? Doesn't make sense? I can run my 9 minutes. That is pace. So we need to calculate this pace also. So how to calculate? You know, this is 6.9 mile per hour is right. But to get mean per mile, right? So how about you can put like this? So 1 hour equal 60 minutes, right? So this is 1. But to cancel out hours and hour, I can put here, right? And finally, 60 divided by 6.9, and the unit is mean per mile, is right? So this is why 8.7 min per mile. So how about class? Does it make sense? So you can say if someone exercises outdoor, okay, your exercise intensity per mile is 8.7 minutes. Or if you want to talk about second, that case 0.2 multiply 60, so 8 minutes 56 seconds. How about class? Does it make sense? Per mile is right. So please calculate using this example your speed as well as your pace. Please pause the video and please calculate. So I write down 6.9 mile per hour here, and my pace is 8.7 min per mile. How about class? Doesn't make sense? You can put 8 minutes 56 seconds like this. It's no problem. So please write down your pace. Your speed as well as mile per hour, and please show your work here, speed, and please show your pace here. How about class? Does it make sense? You can check your answers here. So how about this VO2? How can you get this VO2? Using your exercise intensity math is right. Just multiply 3.5 is right. Did you remember? You have this number, right? Please check. And did you remember using ACSM equation? Minus 3.5 and divided by 0.2. Please go back to the slide if you couldn't understand. And you got a meter per minute. But meter per minute, it should be calculated divided by 26.8. So you have a mile per hour. This case, 6.4 mile per hour is right. To get a pace, did you remember? 60 divided by the mile per hour is right. Mile, right? So that is 9.4 min per mile. So this is kind of an answer. So please check your answer, and if your answer is correct, please write down and show your work. If you're not correct, right, please go back to the hour slide and practice again, and please do that. We are almost done. So we have like speed is right, 6.9 mile per hour, and you have your own speed, and we have 8.7 min per mile, pace 2. So this case, if someone who exercises outdoor, they usually want to know their mile. How about class? Doesn't make sense? So how many miles should I run? Like this kind of approach is right. So this case, we should calculate mile also, and I'll show you how to calculate mile. So to get mile, did you remember I said 28 minute 46 seconds. This is minute and second. But did you remember I said keep in mind should maintain your decimal number minute is right. 28.77 minutes is right. So for me, this is my exercise program to use 400 kilocalorie to metabolize 400 kilocalorie. I need 28.77 minutes is right. And another one, my pace, because this is for person who outdoor, so we need this kind of number. So my min per mile pace is 8.7 is right, 8.7 min per mile. So I can put like this. So 28.77 minutes, put here. And my pace, I can put my pace like this, mile first and 8.7 minutes. Why? Because I can calculate, cancel out minute is right. So that case only mile. So I think my mile is around 3.3 mile. So this is kind of my mile. And please calculate your mile. Please pause video and calculate your mile using exercise time, decimal number time, as well as your pace. So please calculate your mile. Yes, please check your mile. So here, this last column, your mile here is right. So how to calculate? Did you remember? You need the exercise time duration, the decimal number one. How about this case? 34.2 minutes. Using this one, as well as you should know your pace is right, 9.4 min per mile. So using this one, you can calculate your mile. How about class? Doesn't make sense? Yeah. So please check your mile. If you check, yes. If your answer is correct, please put your mile and please show your work here. So I believe you have all numbers right. Your name with max value, body mass kilogram, right? Your mat number and your speed and pace, your mile, kilocalorie per minute, and time. I believe you already show your answer is right. So please include this one to your lab 4. How about class? Doesn't make sense? Doesn't make sense? Yeah. So if you use Dr. Kwon's virtual lab for your lab 1 and for your lab report, yeah, but still the exercise part you do not need to use Dr. Kwon, your own one. Today I show you here is right. Yeah. So if you test your 1.5 mile run test, if you test your 1 mile walking test, that case you just include your exercise program. Today we did is right. How about if you use Dr. Kwon's virtual lab for your lab 1 report? Yeah, it's okay. Please use. But exercise part, please include this one, your one, to your lab report for. I think that's it.